With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So the question is, in the given diagram, the block of mass 2 kg and 3 kg are placed one over the other. The contact surface are rough. That means there is a friction between these blocks and surface. With coefficient of friction, mu1 is given as 0.2 and mu2 is given as 0.06. A force of F, that is half T, and I can say 0.5 T Newton, where T is in second, is applied on upper block of the direction. Given that the value of G is 10 meter per second square, so we have to calculate the relative slipping between the blocks occurs at what time. Okay, so to solve this problem, first we have to make the free body diagram of these two blocks. Suppose this block is my block first and this block is my block second. Suppose 2 kilogram of block is my first block and this is my second block. To solve this problem, first we have to make the free body diagrams of these two blocks. Okay, so free body diagram, first we have to make the free body diagram of 2 kilogram weight, 2 kilogram. As you can see that in this block, the force of 0.5 T is acting in this direction. This is the force which is 0.5 T is in this direction. Now, when force is acting in this direction, that simply means that the friction force is acting in this direction, because friction force is always generated in the opposite direction of the force. So this is the friction force. Suppose this is F1 because this is my block number 1. Now the weight of this block is acting vertically downward, that is mg, or I can say 2g because mass is 2. And to balance this force, there is a normal reaction which is acting perpendicular to this block, which is N1. So these are the total forces acting on this block of 2 kilogram. So we know that friction force, maximum friction force, can be given by mu n. So that means F1 maximum, that is equals to mu n. The value of mu is given as mu1 is given as 0.2. Okay, mu1 is given as mu1 n1. So it is 0.2 into value of n1, that is equals to 2g. 2 into value of g is 10. So F1 maximum is coming out to be, this is equals to 4 Newton. Okay, now similarly I am going to draw the FBD diagram of block second, which is my 3 kg block. This is my second block which is having weight 3 kilogram. Okay, now the friction force on first block is in this direction. That means friction force on this block is in this direction, in the opposite direction of the friction force of first block. So the friction force is in this direction, that is F1. Similarly, the second friction force between the surface and this block, which is acting in this direction, this is second friction force, which is F2. Now the weight of this block is acting vertically downward, that is 3g because mg, so it is 3g. Now one normal reaction is because of this first block, that is N1, it is acting like this, and the second normal, which is balance the weight of this block, which is perpendicular to this block, that is N2. So these are the total force which is acting on the block second, which is having the mass 3 kilogram. So I can write for this block that the value of N2, okay, in vertical direction there are three forces, N1, N2 and 3g. So I can write the value of N2, it is equal to N1 and 3g because these both are in same direction, vertically downward. So the value of N2 is equals to N1 plus 3g. 3 into value of g is 10. We already calculate the value of N1, that is 20. This is the value of N1 because N1 is equals to 2g, that is equals to 20 Newton. So I can write N2 equals to 20 plus 30, that is equals to 50 Newton. This is the total normal reaction on block second. Now the friction force for this block can be written as, that is F2, and F2 maximum can be equals to mu2 N2, and the value of mu2 is given as 0.06. Okay, value of mu2 is given as 0.06 into value of N2 is 50 Newton. So the friction force for second block maximum is coming out to be, this is equal to 3N. This is F2 maximum. Now we have calculated both friction force on block 1, friction force on block 2. Now comparing these forces, you can say that my value of F2 is less than F1, because F1 maximum is equal to 4 Newton and F2 maximum is equals to 3 Newton. That means F1 maximum is greater than F2 maximum, and the friction force which is less is behaving like a dominating friction force. The friction force which is less in amount is behaving like a dominating friction force, and the body is moved according to this block. Body is moving according to this force, according to F2 max. That means the value of F1 is greater than F2. That means there is no slipping between them. No slipping. Now in the question they are asking about the time in which relative slipping is start. So first I have to write the force equation for these two blocks. So the force equation for first block can be written as you can see, for first block this is F minus F1, that is equals to 2A. The force equation from Newton's second law I can write for 2 kilogram. The force equation F minus F1, that is equals to ma. The value of F is 0.5t minus value of F1, that is equals to mass is 2a. This is for 2 kilogram. Similarly for the 3 kilogram weight, for 3 kilogram, the force which is F1 on 3 kilogram block is F1 minus F2, that is equals to ma. Okay, in horizontal direction there are forces F1 minus F2, that is equals to F1 minus F2, that is equals to 3a. This is, and value of F2 is 3 Newton, so I can write F1 minus 3, that is equals to 3a. This is my second equation. Now from both equation the value of F1 is coming out to be, the value of F1 that is equals to 4 Newton. Okay, so from both equation the value of F1 is coming out to be 4 Newton. So if I put the value of F1 in equation 1, if I put the value of F1 in equation first, then I will have my time when the relative slipping is start. So after putting this, we will have, first we have to calculate the value of acceleration, because we don't have the acceleration. So if I put the value of F1 in this equation, first I have to put the value of F1 in second equation, then I have my acceleration 4 minus 3, that is equals to 3a. So from here the value of a will be 1 by 3 meter per second square. This is the acceleration. Now I am going to put the value of F1 in equation first, because now I have the value of a as well as the value of F1, so it is easy to calculate t. So 0.5t minus F1 is 4, that is equals to 2a. 2 into value of a is 1 by 3. Simplifying this, we will have the value of t, that is coming out to be 28 by 3 second. So in this time the relative slipping will start between them. T equals to 28 by 3 second. Okay, so just check the answer. The third option, which is 28 by 3 second, is the correct option. Okay, thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.